So now I'm going to go through this question that is found in your assignment F2, question 16. So the question is about SO2 and it's being formed by two different processes, the contact process, which is over here, as well as the oxidation of SO2 catalyzed by the nitrogen dioxide in the air. So these are two different processes which shows how SO3 is formed. Okay, and then SO3 is then used to form the sulfuric acid. So the question is more about the mechanism of the kinetics, all right? And there are some steps shown here. So for contact process, you are seeing the mechanism. For the atmospheric oxidation of SO2, you are seeing the mechanism as well as an overall equation. Okay. So let's look at the SO2 in the contact process for the first one. So we are seeing SO2 being formed here and here. So in the contact process, we are seeing SO2 being formed after the first step, and then subsequently it is used up as a reactant in the second step. So the term that we use to describe SO2, which is a product that is formed in the reaction and subsequently used up as a reactant, is known as an intermediate. So we will call SO2 as an intermediate. And then what about NO2? NO2 in the next step, you can see in step 1, it appears in the reactant site, right? Is something that you put in and it reacts away, it's gone. Okay, and then in step 2, after the end of step 2, you are seeing that being formed back. So it is regenerated. So we are seeing NO2 being something that we put in, is used in the reaction and subsequently is regenerated. So the term that we use to describe such a thing is called catalyst. And how do we even confirm further that it's a catalyst? You can see that in the overall equation, there is no NO2 appearing. Because for an overall equation, usually we will just display the reactants and the products. So we are not seeing the catalyst. Okay, next question. So we are seeing this energy profile diagram, and this is in the absence of NO2. Okay, remember what was the role of NO2? It was a catalyst. So on the same diagram, we are going to sketch the energy profile diagram for a reaction that is now carrying out in the presence of NO2. So we will expect that the function as the way the catalyst does, it lowers activation energy, it provides an alternative pathway without affecting the enthalpy change of a reaction. So we are seeing that a lower activation energy will be something like this. So the initial and the end and the ending part is the same. Now we are seeing a lower EA, which is catalyzed. Okay, so that's the energy profile diagram for the presence of NO2. Okay, next question now. Oh yeah, before we go to the next question, an interesting observation from some students is that, Madam, but if you look carefully, the reaction above is actually two-step. So they're telling me, oh, madam, the reaction is two-step. So what don't we have to draw an energy profile diagram that shows two-step? So I would say yes, we have to draw that. Okay, so I'm accepting both versions of answers. So if we are looking at the previous version of answer that I'm showing you, that is just to illustrate the effect of a catalyst. But if we really want to demonstrate the mechanism that we are seeing, right, we are going to see a different pathway. Instead of one step, we're going to see two steps reaction. And out of the two steps, unfortunately, they did not state which is the rate determining step. So, I mean, if we're going to assume that, let's say the first step is the rate determining step, then we will have to show it having a greater activation energy than the second step. But overall, NO2 is a catalyst. So we will be expecting a lower activation energy. So for those who follow the mechanism and illustrate a two-step mechanism, then perhaps what you will get may be something like this. Sorry about that. Something like this. Okay, so I have my first step, which is my slow step, and my second step. So I'm showing a two-step mechanism, and my first step is slower if I state that first step is the slow step. But overall, we are still seeing it having a lower activation energy compared to the original without NO2. Okay, we are still seeing a reduction due to the NO2 acting as a catalyst.